record on the computer. And if you want to, let's take a photograph to indicate that you put in the effort in this class. So I suggest we actually finish later than on Tuesday. On regular Tuesdays, you don't have anything planned afterwards. Yes, guys? It's a reading day, so there are no other classes, it's just me. So, guys, of course, if you could, I mean, I only see very few people, it makes it so much more boring to teach it. So if you could turn on the cameras, I'll be really happy to see you. All right, so this is what we covered so far, guys. With integration, we know the sigma notation. So if I write something like this, I mean it to be A1 plus A2 all the way to AN. And we observed several summations that are very easy to figure out. So first summation is summation where k is 1 to n of just a constant. So constant c. That would be just c plus c plus c, which means it is n times c. It's n multiplied by c. Good? That's one thing we learned. Then we have another summation that we can fairly easily figure out. And that's the summation where k is 1 to n of k. That happens to be the last number times the last number plus 1 divided by 2. Then thirdly, we can figure out, and that's what we did last class, I believe, you can take the summation k equal 1 to n of the square, and we talked about the technique definitely. And that's equal to n plus 1 to n plus 1, if I'm not mistaken, divided by 6. I always forget it, and I always verify it from scratch. And identity 4 is that the summation where k is 1 to n of k cubed will end up being n plus 1 divided by 2, and all of it squared. We're going to use those identities in one moment. Well, examples of this, well, one second. So for instance, suppose that I asked you to add up 1 plus 2 plus 3 plus all the way to 10. You would say the answer is what? You don't need to simplify it, guys. Just tell me what's the answer. For 1 plus 2 plus 3 plus all the way to plus 10, what's the answer? Almost, Francis. You forgot to do one last thing. So the answer is 10 times 11 divided by 2. So the answer is 55. That's how this formula is useful. Okay. Now this you should all know how to establish, guys. Why is that so? Because look at it. What you can do. You can say that s is equal to 1 plus 2 plus 10, and you can say that s is equal to 10 plus 9 plus 1. Now look at it. When I add it up, I get that 2s is equal to 11 plus 11 plus 11. Do you agree? Now, how many times am I adding 11? 10 times. So that's just 10 times 11. You see what's happening? And so s is equal to 10 times 11 over 2. Do you see how I can very, very quickly establish this formula? Yes? Now, in my notes, I already went over that, I believe. I'm sure I did it with the other class. I did go over it with you, correct? I mean, if I add up numbers like this, if I say, let's say, what is 1 squared plus 2 squared? well, let's take in front. So plus 2 squared plus 3 squared, let's say over 2 plus 5 squared. What's the summation in that case? The summation is going to be 5 times 6 times 2 times 5 plus 1 divided by 6. So if I'm not mistaken, the number is 5 multiplied by 11, which in this case also happens to be 55. Yes? That's the idea. Now, why it works? How did I do it? How did I do it? Because I understand. So I understand those ideas. Look at it, guys. What's the idea of proving this? You see, so this is the same as S equal to the summation K equal 1 to N of K squared. That's what I'm considering, right? I'm considering this summation, and I want to know what's a very short way of adding those terms together. Now, what do? It's a trick, guys, and this is the trick that if you understand it, then there is nothing to remember. The trick is something known as telescoping sum, a telescoping series. This is the trick. So what I do is I consider instead this summation. And that would be K plus 1 cubed minus K cubed. Notice that it looks like I made something much harder, right? I wanted to figure out the summation for K squared, but I am working with the summation for K cubed. Are you with me? For K cubed. Now, why is it much simpler, guys? You have to look at it and tell me what am I truly adding up. Look at it. You see, first of all, I can very easily figure out this full sum. It's a very, very easy sum. Why is it a very easy sum? Because look what happens here, guys. If I look at this part, I am adding 2 cubed plus 3 cubed plus 4 cubed all the way to plus n to the n plus 1 cubed, right? The last term is n plus 1 cubed. And what am I subtracting here? I'm subtracting 1 cubed, 2 cubed, 3 cubed, all the way to n cubed. Do you understand? So whatever I add, I also subtract almost all of it. What survives is simply n plus 1 cubed minus 1 cubed. Now, I want you to very quickly, do you understand what happened here? That I know the summation right away. It's n plus 1 cubed minus 1 cubed. Confirm if you understood. Write very fast, guys. I don't have time. Write why or no if I need to explain something more. Very fast. And the rest of you see, guys, it's very simple. No or yes. So a lot of you are saying no. Guys, what you see here is a big problem here, is that you look at the formula, but you're not reading and not thinking about what it means. What am I doing here, guys? What is this expression? This expression, let me put it in red. What is this? Look at it. This means, you see, K is 1, so it's 2 cubed minus 1 cubed, right? Plus, what next? It's 3 cubed minus 2 cubed. That's when I put 2. When K is 1, it's this. When K is 2, it's this. Then on all the way until I reach to the last term, which is n plus 1 cubed minus n cubed. Do you agree? So here, again, what I wrote in red, do you understand that this is just translating that sigma notation into expanded form? Yes? Confirm, please, that you understood this part. Thank you so much. Okay. Now, what is this part equal to? Look at it. Do you see? I have the summation of the numbers cubed all the way from 2 until n plus 1, and I subtract from it all the numbers cubed from 1 to n. So what have I removed? I removed everything except the n plus 1 cubed, and there is nothing canceling 1 cubed. So the result is simply this is what survives. Right, guys? If I give you $2 cubed and $3 cubed and $4 cubed and n plus $1 cubed, and I subtract $1 cubed, $2 cubed, $3 cubed, all the way to n dollar cubed, how much do you have left? You have n plus 1 cubed dollars left minus $1. Yes, because I gave you a lot of things and then I removed most of it. As simple as that. That's why we have this summation. Yes, so this is n plus 1 cubed minus 1 cubed. Good. Now what next? Next is then I look at this summation. I'll keep it. Now the other thing I can do. Look at it. Now let's move from here and say that this is also equal. Look at it. I can simplify it inside. Expand and simplify. So this is k1 to n. Now this becomes, how do you expand k plus 1 cubed? It's k cubed plus 3k squared plus 3k plus 1 minus k cubed. You agree? This is what happens if I expand the cube. And what do I have left? Look at it. So this expression, I mean, the k cubes are actually cancelled. Yes? And then I see here, I can describe the sum as what? As 3 times the summation k equal 1 to n of k squared plus 3 summation all the way to n k1 of just k plus the summation k equal 1 to n of 1. That's what this becomes. Do you agree? It's just a sum, right? So if it's just a sum, I can group terms together when I do summation. This, guys, I hope you understand. So the only thing I do not know and the only thing I actually want to understand when I do this expansion here. Do you see this, guys? This is what I am searching for. I was interested in this equation to figure out the summation of k squared. Now everything else, anything else, I understand very well. Let me put it in green. What is this, guys? This is equal to what? It's equal to 3 n plus 1 divided by 2. Do you agree? And tell me, please, what is this equal to? Come on, guys. This is so simple. This I want to answer immediately. What are we doing here? We're adding 1 to itself many times. No, you're missing again. Guys, what does it mean, the summation? When k is 1, I put 1. When k is 2, I add plus 1. When k is 3, I add plus 1. So I am adding 1. This is the expression I'm adding as long as k hasn't reached the number n. I'm just adding it and adding it and adding it. You see, it depends on k. So it's 1 plus 1 plus 1. So how much do I get? Do you understand, guys, what this means? This is just how is it working? It's as k is moving 1 unit up at a time until it reaches n, I add those terms. Now here I add these terms, which is 1. So what is the summation, please? N. Thank you so much. It's n. Because it's 1 plus 1, how many times? From 1 to n. So I add 1 to itself n times. So this is just n. Clear? Now what do you get? What do you have here, guys? You have this orange is equal to so 3 times the orange is equal. You see this expression equal to this expression. So now you just simply solve. All you have to do is write. What is it? So all you have to do is just write n plus 1 cubed minus 1 minus 3n plus 1 and minus n. Yes, this is and this I have to multiply by 1/3, and that will give me the summation k1 to n of k squared. Yes? And so what do we get? We get that, yeah, so this you can simplify altogether. You can simplify it, guys. Now what do you get? You get 1/3. This you can write as, you can write this as 2, sorry, it's Well, I mean, let me actually not waste my time and simplify it. When you simplify it, guys, it just now it's algebra. When you simplify it, you should get n plus 1 times 2n plus 1 divided by 6, okay? If you simplify it like this, you should get this formula. You should, when you go home, you should do the calculations. And again, guys, I only see one person. Come on, turn on the videos. I would like to see who is here. Good. This is the summation that we have, and you should think how to figure the summation where it's cubed. What's the idea? Okay, this guys, if you understood the concept, then you should be able to carry the idea with cube. A good student, that's exactly what they do. A bad student doesn't. We'll see. I mean, if it comes to failing the exam, you know, I will consider giving 10 points extra credit. You see, for those that at least try. Why only? I mean, you had one exam you haven't done, one exam that you had done at home forever. That's only, right? You mean, why is it so much is the question. Here is, we are now at a very important point here, guys, extremely important. I teach probability, and people that understand ideas really at their heart, the calculation is easy. It's very natural. All right, so what is this problem, guys? The problem is the area problem. How do we find the area below a curve y equals f of x over the interval ab? You see? In mathematical notation, this is written like this: integral from a to b f of x dx. That's we will see why that's the right notation for it. Okay, so first, obviously, why would anybody in the right mind be suddenly thinking about, well, I need to find the area below a curve? Well, as it happens, guys, that here is a simple example that's very useful, for instance, in biology or in any statistical inference. So suppose, for instance, that's what they show in probability, suppose that you want to measure the illness, the prevalence of an illness in the general population. And then you pick for that a random sample of 1,000 individuals and find that 50 of them have the illness. The question is, what can be said about the prevalence of the disease in the population, given this information? And as it happens, guys, I'm not gonna explain why I do that for probability. It is the problem for that is integrating this function. You see, finding the area under the curve of the function that I wrote over here. And for instance, you would see that that the probability that the illness is between 3% of the population to 7% of the population is sick. The estimate that it's likely that between 3% to 7% of the population are sick, and this likelihood is with 99%. Okay, it's 99% certain that it's between 3% and 9%, given this information. You follow? If I have a bigger sample, I can make a better and more narrow prediction. And this has to do with area under the curve. And now, of course, in physics, area under the curve will represent conservation of energy, guys, right? So you should know about this principle very well. I mean, how many of you study outside of class? My impression, you conserve your energy, right? So if you could, so that's precisely what the integration is about. You see, any sort of conservation of momentum law, conservation of energy law are really related in their most fundamental form to the area problem. You can translate it and say that the reason it's happening is just area under the curve is something. Okay, and let's now try to understand the idea, guys. What do we do in calculus? We are using some pixel, right? We're using a pixel, some sort of simple instance of the problem we're trying to study, and then use that to describe more complicated phenomena related to that thing that we study. So, oh, good. I see. So, guys, let's see if you can imagine it. So, what is the easiest instance, right? So let's say what we did when we studied curves. So all we did this semester, we studied curves. Now the simplest curve is a line. And so we can imagine that a curve is many lines. Now let's say, what's the simplest area? What's the object for which area is very easy to calculate? Square, precisely. And then you can, of course, if you know squares, you can use rectangles. Right, not just a square, but a rectangle. It can be long or short. Rectangles are a bit more flexible. So that's what we are going to do. A rectangle is the simplest area we can think of. Yes, and now the area of a rectangle is height times width. The reason it becomes so, it's because, look at it, guys. A rectangle of width 2 and height 4. How many rectangles does it contain? It contains 8 rectangles. Do you agree? 2 and 2 and 2 to add it to itself 4 times. So the reason that it's height times width is it begins from counting, right? Just how many squares, how many tiles can I place in one rectangle? Okay, so here is the idea, guys. It's a very simple idea, but you just have to get used to the notation. Here is an arbitrary curve. Do you agree? It's an arbitrary curve, and what I can imagine is that underneath that arbitrary curve, I will place very, very thin rectangles. Can you see it? There are going to be many, many very thin rectangles. And then let me see, before I say it, guys, what will I do with those rectangles? My goal is to measure the area of the curve between A and B. So I will place lots of very, very thin rectangles underneath. And what would I do? Please tell me in the description or speak. What would I do with those rectangles? Some areas, very good. Well, the more the better, the thinner the better, Francis. It's an approximation, right? So you just make them very thin and you place lots of them. The thinner you make them and the more you place, the better is your approximation. Yes, so it's not a matter of, because when you place rectangles, as you can see over here, you are making an error. We will show it, of course. I mean, but this is an error. You see, I'm trying to explain to you why, guys, the area problem is described this way. You see, why is this integral sign, the numbers here, and what it means. You see, so in general, from A to B, this elongated S sign fx dx. Why is that the notation for finding area under the curve? Now, for a very, very easy reason, guys. Look at it. If I stacked a lot of rectangles that are very thick, their thickness, here it is, their thickness is dx. And the height of an arbitrary rectangle at x is fx. Do you see? So the area of an arbitrary rectangle that stands at x is fx times dx. Please confirm if you understand. It's just notation. It doesn't right away tell me how to calculate anything, but notation-wise, I'm trying to use symbols that convey the idea of how I'm going to find area. Yes? Very clear. It should be extremely clear what the notation means, guys, because if you understand what something means, truly, you have control over it. So here we go. This S stands for sum. and you're summing rectangles from A to B, and the height of an arbitrary rectangle situated at x is f of x, and its width is dx. So that notation should remind you what you have to do. It's like a cheat sheet. You understand? The notation tells you what's the idea, what must be done to calculate the area. I hope it's clear. Okay, and then the next lecture, we actually are going to carry this calculation, which is happening right away. Here is again that picture, guys. I didn't draw all of them, but you can see here are many very thin rectangles. Do you see that the tip of those rectangles, because they're so thin, forms the curve, forms the skyline? Yes. And here that means just we have this just means sum all the rectangles in such a way that the rectangle at x has altitude f of x and width dx. So that's the area. So and that S sign stands for summation. Yes, this elongated S means sum. So how are we actually going to carry this out? It's obviously going to be done using a limit. Okay, guys. So we are going to make the width of each rectangle to be the same. You understand? We're going to imagine, what I imagine personally is that I'm in a construction site and I'm building skyscrapers. And those f of x are the altitudes of those skyscrapers. Now, let me try to understand how to do that calculation, guys. So we're going to build altitude at what I call Rn. That means using the right endpoint of each block, of each city block to erect the altitude of my rectangle. So if I have to integrate from A to B, look what I'm going to do, guys. I'm going to divide this region into n parts. The bigger the n, the better is my approximation. Do you understand? So I want to create n rectangles, where n is maybe 1,000,000 or 1,000,000,000. The more, the better. In arbitrary symbols, just n rectangles. Before I continue, guys, do you understand what I mean by n rectangles? N will go to infinity when I approximate area, because I want to create as many as possible, approaching infinity, and hopefully that will also make them very thin. Yes. So what I'm trying to achieve is a sort of picture like we have here, and even better. So here you can see many rectangles, but they're all still very thick. Dx is just an idealized thickness. I want dx to be very thin, so I'm going to make n huge for that. So here is how the construction will go about, guys. I will create n rectangles where the width of each rectangle is delta xn, and it would be the full length divided by n. Do you see that? And then xk is the point at which I erect the altitude for the kf rectangle. So this is for first rectangle, altitude is erected at x1, at second at x2, at third at x3, and so on and so forth. The R stands for right-hand point. I will always pick the right-hand point. Are you with me? Now, guys, here is how we are going to begin, right? So how do I figure out what is x1? You can describe how to get to x1 starting always at the point A. So x1 is starting from the point A, displace 1 delta x. You see? Displace 1 delta x. So it's A plus 1 times B minus A over N. That's one block. And that's where you are going to create the point x1. You are going to evaluate it at F to build the altitude. Is that clear? Before I continue, is it clear what I need? The x1, guys, is the point at which I build the altitude. That's what I try to indicate by this diagram, you see? It's basically how do I construct those rectangles? You see here is x1 and here is the altitude. You will see it in a moment. I have to describe the blueprint and then we will actually carry calculations. Yes, you will actually carry calculations to help me. So first I need to describe those points. So x2 will be to displace 2 blocks from A. x3 will mean to displace 3 blocks from A, and so on and so forth. And in general, k means displace k blocks from A. It's A plus kb minus A over N. Yes? So this is my formula, guys. This is my formula for constructing rectangles using n right rectangles. It means I will take f of a plus k b minus a over n. That means the kf block, the kf point at which I erect altitude, times the width of the rectangle, b minus a over n, and I add it up. And that will stand for an approximation for my area. Are you with me? It will stand for the approximation for the area. And I will take limit as n goes to infinity to make the width of the rectangle very thin and to have a lot of them. So this thing will mean the limit of the right-hand sum, and that will be this. Okay, let's try to calculate what it is with a particular example. Are you ready? All right, guys. So first of all, suppose we are integrating from 0 to 2 of x dx. Let's begin something simple. Yes, integral from 0 to 2 x dx. So first of all, I think, what is the shape? At any x, it's x. So what I'm integrating, what I'm finding is the area of a right triangle with sides 2 and 2. Do you agree? So in fact, I don't even need to use any complicated procedure. I right away know that the answer is 2 times 2 divided by 2. So the answer is 2. Because the area of a triangle that I drew here is 2. Confirm if you're with me. You see, guys, one thing which is troubling a lot of you is that you are not thinking deeply about what the statement means. It's not just a mathematical formula. Ask yourself, what is it? And if you can answer it in simple language, then you understood it. A lot of difficult ideas have a very, very simple origin. So I see that that this integral, look at it. What am I asked to do? I'm saying, okay, add up the areas of microscopic rectangles that are built from 0 to 2, and at the point x, the altitude of the rectangle is x. So that means that's the skyline. At x, it's x. So I have y, the altitude y is y equals x. So I see that I am integrating below the line y equals x from 0 to 2. Are you seeing what I'm saying, guys? And then I see what shape I am actually finding area for. I'm finding the area for a triangle. Right? The base and height are the same. I'm finding the area of a right triangle with base 2 and height 2. And the area of that triangle happens to be 1/2 base times height, which is 2. So without any calculus, you understand, guys, my point, right? Without any calculus, no, of course not. Without any calculus, it's not always a triangle. Just in this case, it's a triangle. But without any calculus, because I understood what this thing is trying to accomplish, I can accomplish it in an entirely different way. You see, if you know what a person is trying to describe, if you understand the intentions of somebody who is doing it, you can sometimes pick a different way of accomplishing that intention. Do you understand? It's a matter of not just doing. You see, you're not just a worker. You're not just a builder. You are a strategist. If you understand intention, you can accomplish the same goal by other means. And that's very important. So the answer without any calculus is 2, correct? Let's see with calculus that the answer will be 2, just to be to convince ourselves that this procedure should work. Are you ready? Here we go, guys. So what is my width of the rectangle? So what I do is I take delta x n, and it means I take this length, and I want to create n rectangles. So this length is 2. I take 2 divided by n is the width of one block. Are you with me? The width of one block is 2 over n, where n will be huge. And n is like, think of it like a million or billion or something, some very huge number, so that the rectangles are tremendously thin, like hairline thin. Okay, and then what is the point xk? I need to know where the altitude will be constructed. The general point xk where the altitude is constructed is, if I describe it from 0, it's 0 plus k times delta xn. 0 plus k times delta xn. You agree? Do you understand what I mean by k, guys? How do I get to the first construction site, to the point x1? I'd say 0 plus 1 block, move 1 block. To the second side, I say 0 plus 2 blocks. Are you with me? Confirm yes or no, please. I need a lot of confirmations. Yes, completely with me, guys. You have to imagine. Can you imagine it? I will test in a moment if you can do it another way. Okay. You are just describing how to get to the construction site. So xk is the construction site at which altitude is erected. And that construction site for an arbitrary point k is k times 2 over n. Now, what does f do to the input? What's the altitude? The altitude at that point is f of k times 2 over n. Do you agree? But the function f of x equal to x means that the altitude is the same as the position. There is nothing done to this point. So the altitude happens to be k times 2 over n as well, because that's the function. Are you with me? Guys, very important step. It requires initially a lot of imagination. Do you see what I'm doing? Very simply, I'm building those rectangles. What do I decide to do? I decide to build them from the left point and move to the right. So I'm going to go to x1, x2, x3, all the way to xn. So I want to describe a general motion to the point xk. I don't want to say x1 and then x2. There are too many points. I just want to describe a general motion to some arbitrary point. If it's xk, it means displace k units from initial position. Yeah? Beautiful. So now look what happens. Look what happens, guys. So this is f of k times 2 over n and just k times 2 over n. So now all I have to do, the area of all the rectangles combined, is the summation from 1 to n of fxk delta xn, which in this case, what is f of xk is k times 2 over n. What is delta xn is 2 over n. Do you see that number? So it's I need to figure summation k1 to n of k 2 over n times 2 over n. I packed it all together. Yes? Now what happens here, I can factor out 2 over n squared. You see that this k is the only thing that depends on n, so it's the same as 2 over n squared, summation of k. So I'm adding 1 plus 2 plus 3 plus 4 of only k, which is 2 over n squared times n plus 1 over 2. The summation I can replace by this formula. Yes? And what does it become? It becomes, in the limit, guys, I push n to infinity. When I push n to infinity, this is this limit, which I right away see. What's the leading power here? The leading power is 2 squared n squared. The leading power here is 2n squared. So it's 2 squared over 2, and the answer is 2. So it works. You see, using those tiny rectangles, I arrived at the same thing that I knew geometrically without any effort. Without any effort. Here is a quick test, guys. Maybe a challenging one. You see, I want you to, so in some languages you write left to right, and in others you write right to left. You agree? I want you to tell me how to do this process by instead of moving like I showed before, like we moved it like this, guys. You see, we moved like this. We said here is 0, then here is x1. And then here is x2, right? And that's how we moved until we reach the number 2. Yes? I want you to try to describe the summation if I decide to move in the opposite direction. If I decide to start at 2 and move in here. So this would be x1. This is x2. And so on until you get to 0. Can you do that? Same idea, but I want you to show me that you can construct a Riemann sum moving from 2 downwards to 0. You see, guys, this if you can do that, it gives you a lot of flexibility. That means that you really understand how that works. Well, I mean, you do it, you have to think about it, Jahin. Limit-wise, you just partition it into n parts, right? And then, so you write the formula for n parts, and then you take the limit. So reaching it or not, it's just, the idea is that you have lots of rectangles. That's what you actually do in practice. You have lots of rectangles, maybe millions of them, maybe trillions of them, and then you see the area almost perfectly with enough of them. All you have to do, guys, is describe the xk. I mean, same delta xn, you agree? Just what's the xk? So I'm going to wait 1 minute. Tell me what's the xk. All right, I think more than a minute passed. All right, more than 1 minute passed, guys. Let's see how to do that. So again, I want you to move in this direction. Yes, so this is 2, this is x1, x2, and so on. So what's the xk, guys? So what is x1? X1 can be thought of as 2 minus 1 times 2 over n. Do you agree? The distance from here to 0, it's 2, and 2 over n is the distance of one block. Just to start from 2 and move back, minus, right? So what is x2? It's 2 minus 2 times 2 over n. And what is x3? It's 2 minus 3, 2 over n. And in general, xk is 2 minus k 2 over n. Are you with me? It wasn't, you see how you can quickly get it, yes? So then my area is approximately, this is my summation. So I sum from k1 to n, and I add up the function f of 2 minus k 2 over n times the width 2 over n, which in this case f doesn't do anything. So it's the summation from 1 to n, 2 minus k 2 over n times 2 over n. Yes? And then let's see what the summation is. So this summation is k equal 1 to n of 2 times 2 over n minus summation k equal 1 to n k 2 over n squared. Yes? And so what am I going to get in the summation? So this summation is, I add 2 times 2 over n times. So this would be 2 times 2 over n times n. Minus this part is 2 over n squared n plus 1 over 2. And what do I get? I get 4 minus what we had before, minus 2 over n squared n plus 1 over 2, which if I push n to infinity will become 4. Look at this limit. It's the same as 4 minus 2. You see this limit is 2 squared over 2, which is 2, just like I promised before. Do you see? Guys, you have to be quick at calculating limits at infinity, that they are easy usually. And you have to be, you just have to see, it's very simple description. If you were standing at 2, how do you go to 0? Is it clear what I did? Let's try the next problem. What do you mean formula was given? I mean, if you understand what you're trying to do, then which formula? I mean, if you understand what you're trying to accomplish, that you're trying to add up areas of rectangles, then it's very easy to figure out the ultimate answer. All right, guys, let's do one more with you. You're going to calculate integral from 1 to 4 of 2 plus 3x. Can you do that? I want you to calculate the integral from 1 to 4, 2 plus 3x dx. Please try to be fast. I will give you 5 minutes. Francis, that would give the answer, correct, but why does it give the answer? That's the question that we're trying to understand, you see? So you can try to do both. Giovanni, it's supposed to be area. All right, let's do it together, guys. And you should work at home and be faster at it. First of all, Francis and some of you, because of our previous lectures, without knowing why that works, the answer will be the same as if I take 2x plus 3 over 2x squared and evaluate from 1 to 4. Do you agree? That's what we were doing before. And that should be 2 times 4 plus 3 over 2 times 4 squared minus 2 times 1 minus 3 halves times 1. You agree? So we are expecting to have what? So we're expecting to have here 2 times, this is 2 times 3, so it would be 6 plus 3 times 6 times 8 minus 3 times 2. Yes, something like that. Good. Now, how do you do this thing? Why would you? So I simplified it. I just took this and you know, so it doesn't matter. It's just this number is what you used to get. Now, how do we do it? What's the Riemann sum tell us to do? So it's the integral from 1 to 4 to, what was that? 2 plus 3x, yes? 2 plus 3x dx. So I need to figure out what is my xk. My xk will begin with 1 and displaced by 4 minus 1 over n times k. Do you agree? You understand what I just did, guys? I construct this is the site at which elevation will be created. So then you understood how I got xk? So that is simply 1 plus k times 3 over n. Yes? Okay, would anybody answer why is it plus 1? Why is there plus 1 here? What is the 1 doing? You have to imagine where you are. I mean, here is the 1 and here is the 4. So you begin walking from 1 in this description, and here is x1, x2, xk. How many blocks will you move? So this is first block, second block, all the way to kth block. And the width of the block is 3 over n. That's just the width of the block. Yes? How could it be always plus 1? Where do you begin? Where do you walk? It depends on the, it's like, will you always be taking the Q train? You're asking me, right? I mean, I don't know where you're going. Yes, do you understand, guys? It's where you decide to begin your journey, and then how many blocks do you displace to get there? Yes. So what happens now is then we have f of xk. And what does it do to the function, to the input? It takes 2 plus 3xk, which altogether is 2 plus 3 times 1 plus k 3 over n, which I can simplify if I want to as 2 plus 3 plus k times 9 over n. I just distributed 3, right? So it's 2 plus 3 plus k 9 over n. So it would be the same as 5 plus k 9 over n. So far, good? And then what do I need to do? I need to take this 5 plus k 9 over n and multiply it by what, please? Please, in your comments, if you understood the list bit, what do I multiply it by? Simplest question. Thank you, 3n. Because the width of the block is 4 minus 1 over n. So by 3n, that's the width of the block. That's now the area. Yes? And then I simply break the summation. It's what? It's look at it. It's the summation k equal 1 to n of 5 times 3 over n plus the summation k1 to n of k 9 over n times 3 over n. Yes? And so what happens next? Do you see the summation, guys? Could you tell me what this adds up to? What does this add up to? This is what? Please tell me what this thing adds up to quickly. Yes, which means simply 15, correct? It's this number times n, which is 15. This is 15. And what does this add up to? Notice it's k. So what does this add up to? This adds up to n times 9 times 3 over n squared times n plus 1 divided by 2. Yes? So what do we have? We have 15 plus 27 over n squared times n plus 1 divided by 2. And in the limit, as n goes to infinity, this becomes 15 plus 27 divided by 2. If we didn't make any mistakes, that's the answer. Let's try a simple one, guys. Your turn again. And this time we're going to go with x squared. And to the best of your ability, you tell me what is that? What is the now? This cannot be done geometrically at all. This one could be done geometrically, but if I integrate, let's say, from 0 to 1 of the function x squared, I want you to see what is the integral from 0 to 1 of x squared dx. You can use a shortcut, but my interest is, do you understand how the Riemann summation produces the right result? Shortcut, you don't understand why it works. All right, so what's going on, guys? It should take a minute. Should take a minute. Why does what matter, Francis? So it should take a minute. So first of all, you can verify your calculation with that shortcut. The shortcut tells you that the answer is 1/3 x cubed, evaluated from 0 to 1, correct? So the answer should be 1/3. The answer should be 1/3. Now, guys, again, right, I'm sure that some of you think, if I can do it so simply, why bother with Riemann sums? Well, that means you completely misunderstand what you are trying to accomplish with mathematics. Your simple trick comes from deep understanding, like many other tricks will come from deep understanding. The fact that you can do a trick, nobody is impressed by that. See, those formulas you can play with them. You can achieve certain deep understanding. So this is what happens. So we have from 0 to 1 x squared dx. I'm going to create a Riemann sum for it. So I first begin with creating a x sub k, guys. What is x sub k, please? Type what's x sub k. Very good, David. So the interval is 1 minus 0 divided by n, and I need to multiply it by k. So it's k times 1 over n. So what is f of x sub k, please? The x sub k is the base at which I construct altitude for my function. By the way, guys, consider coming to the evening section if you want to practice those ideas, right? Today it's a bit longer. What is f x sub k? It is this thing squared. It is k times 1 over n squared. So I need to calculate summation k1 to n, k times 1 over n squared times what? Times what? One over n. Thank you, Humira. And what is that? This is, if you square it, guys, this is the same as 1 over n cubed. Do you see it's 1 over n squared times 1 over n? K equal 1 to n of k squared. Why would there be a 1? Well, it depends. If you want to move from 1, it will be a different formula. If you want to start at 1, you have to move down. If you move from 0, you move up. So this is 0. I start at 0 and I move up. You could have constructed, let's call it, I'll use red color. You could have constructed it from 1, guys. You could have constructed x sub k by moving from 1. That would be 1 minus k 1 over n. You could have done this if you wanted to. You're just deciding direction where to move. It's like why do you move uptown or downtown in your train? It depends where you're located. Where do you start your process? Yes. So this is what we get, guys. And then what is this formula? This is 1 over n cubed. K squared happens to be n plus 1, 2n plus 1 divided by 6. And then I push it to infinity. What's the answer if I push to infinity very quickly? Look at this and push to infinity and tell me what do we get. Of course. So the answer is, I just want you to see that it's 1/3. The answer is what? The answer is from the numerator. From the numerator, I get 2n times n divided by 6n cubed. So the result is 2 over 6, which is 1/3, just like we were doing before. You see, guys, the great point is we want to understand the shortcut, right? I mean, naturally, I will not be doing this process if all I have to do is figure the integral from 0 to 1 of x squared. The point is that if I understand the Riemann process, the Riemann process allows me to create formulas. That's what I do in probability all the time. You constantly create new formulas, constantly, formulas that you never saw in your life. Do you understand what I'm saying, guys? So this shortcut is just one instance, but if you understand the procedure, you create formulas that you never saw in your life. And that's what I'm trying to teach you. That's what it means to do mathematics, to create formulas that you never saw in your life. All right. So again, guys, if you don't mind, would you like to continue a little longer? Let's finish the topic, and because if you want to come in the evening to continue this idea, we have very little time. There are a bunch of other integrals which, if you want to, you can practice. You see, this is you understand the idea of how you sum it up. Some of them are more difficult, some of them are less difficult. Okay, this is the ideas that I want to teach you more. Okay, guys. So if the function is continuous, yes, if the function is continuous, that means that for x that are close to a particular point, for all x between xk minus 1 and xk, look over here, essentially all the altitudes are almost the same. If it's very thin, I kind of made it exaggerated so you can actually see the difference. But a continuous function, if the points are very close, the altitudes here will also be very close. Is that clear? The function is continuous, then close x coordinates correspond to essentially identical elevations, essentially identical things, which means that if the x's here in this interval, any x I can pick in this interval are close, that works very well. Now, that means that the Riemann sum could be done with arbitrary points. So if I divide the interval into n segments, I can truly select any point in that segment to be the altitude of the rectangle. Okay, so I, for instance, can use the left-hand rule to express the integral from a b f of x dx. And the left-hand rule is, you can see I plug in the numbers like this. I use the first number before I displace the leftmost number for each interval. And that means that if I move from 1 to n, I don't want to displace. Let's say for the kth interval, I don't displace to the kth position. It's a plus k minus 1, b minus a over n. Okay, or simply I can say that it's the summation from 0 to n minus 1 f of a plus k b minus a over n, b minus a over n. Yes, this is the formula that represents, look at it. First I use a as my altitude, then I use b, then I use a plus 1 interval as the second altitude. Okay, that's the left-hand summation. And this here is the right-hand summation where I move backwards. You should be able to recognize those formulas and see what is happening. How am I moving in this integral? Backwards or forwards? And which process am I using? You follow what I'm saying, guys? So this process over here, that's a right-hand rule, still right-hand rule. Because here I displace from the last point, look at it, and I actually use the last point, then I displace the next, and then the next. So I don't, you can see when k is equal to 0, I get b there. So now here, guys, you have to, in this example, a through d, you have to translate this Riemann sum into the integral formula. You see, you can say, instead of summation, you can use s, and then you can say, so when you type the answer, what is this? You can say s, and, or simply s, and then you say a equal to number, b equal to number, and the function. dx. Okay, you can type, or just simply you can say, for instance, if I have from 3 to 4 fx dx, and you want to type that, you can say s3 4 fx dx. You can type something like this, and I would understand if you can figure it out. Good. All right, guys, very fast. What's the answer to A? Can you figure out what is this construction? What are they building? Integral for what function? Very good. Very good. 2 people answered. What about the rest of you? Okay, 3 people. Guys, how do you do that? So first of all, where are we walking? We're using the right-hand method because we begin at 3, and you see the plus 2 over n means we're moving to the bigger numbers. Yes, we're moving from 3, and where do we end up going? So you can see that we begin at 3, and when k is equal to n, we end up going to 3 plus 2. So k is equal to n, it would be 3 plus 2, or 5. And what's the function? This is the xk. So the function is x squared plus 1. This is the dx. Okay, it's a very important ability, guys. Good. This is the integral that we are doing for A. This is it. Now for B, guys, I want you to take a minute. Tell me what's the integral. Very fast. Okay, some people are doing that. All right, look at it, guys. So if k is 0, then I'm at my initial point. You see the plus indicates I'm moving to the bigger points, right? So my initial number is -1. The last number is -1 plus 4, or 3. -1 plus 4 is 3. The function is x squared plus 5x plus 7 dx. What is this? Look at it, guys. So there I move to the right, so I can think of it as the integral from, for C. What's the answer for C? Integral is from 0 you see, not from 0, sorry, from 1. You can do it from 1. You see it's 1 here, all the way to 2, because it's 1 plus 1 all the way to 2 of root x plus e to the x dx. You getting it? Understood? All I do is I just understand where it begins. The motion begins from the point 1 and goes all the way to the point 1 plus where k is n to 1 plus 1. So that's the 2. And this is the function. And then what is this? What is d? Okay, good. Minus 1 and to 0 of e to the x. Thank you so much. Integral from minus 1 to 0 e to the x dx. Very good. Are you getting it, guys? Yes. So that's the idea. So we have definite integrals. Okay, guys, a little bit, how are you doing? Are you able to work a little longer, or you want to end the lesson? All right, no answer. I don't know what happens to you. So first, guys, here is the idea, the definite integral. So this used to represent area under the curve, but the function f could be negative. And this formula takes a life of its own. Do you agree? In other words, for instance, suppose that this is the curve. If I construct rectangles with altitude f of x, then in the region B, those rectangles are negative. So for instance, if this is representing areas, if this is area, area, and area, then the integral from a to b of f of x dx will be the area A minus the area B plus the area C. That follows because of this operation. It doesn't require the interpretation of being area under the curve to work, right? It just means take the altitude f of x and multiply it by dx. If the altitude happens to be negative, then you will get negative area. Is it clear? So this integral is a minus b plus c. And then we have the following integral properties that we have to understand, guys. So first of all, the integral from a to b of c dx is just c times b minus a. Do you agree? Because in this case, all the altitude is the same, it's just c. So we are seeing that the area is that of a rectangle. Correct? And then the integral from f of x plus or minus g of x is the sum or difference of the integrals. And I can move the constant out. Now let's look at each of them separately. Again, guys, this just means integral of a rectangle. This, if I translate to Riemann sums, look at it, it's just f of x gx dx. I can just multiply f dx g dx. So it's just because dx can be distributed. The width can be distributed. And so the summation will be it's just summation. You understand? This thing is just summation. It's just foiling the x through, and it gives you that form. Formally, this is because we have Riemann sum. Formally, this integral is a limit of Riemann sum, and I can break the Riemann sums into two separate Riemann sums. Here is one, here is the other. Yes? The reason I can move out a scalar from the integral is because I can move a constant out of, I can factor a constant out of a summation. Yes? Here it is. Now, guys, would anybody tell me what's the integral and maybe why? What's the integral from a to a of f of x dx? What's the answer? If I integrate from a to the same number a, what should be the answer? All right, so Giovanni, then if you come on Thursday, you know, then before that, try to read those notes and watch the video. Good luck to you. What's the integral from a to a f of x dx, please? What's happening, guys? What do we do exactly? It's zero. Must be zero because why? Because the width, just this number minus that number divided by n is our width. The width is zero. So we're summing rectangles that have zero width. Doesn't matter how many we will sum, it will be zero. Okay. Here is what happens if I apply Riemann sum. By definition, it's this number minus that number divided by n is my width of the rectangle. Here it is, right? So I just add up f of a multiplied by zero lots of times, which means it's a summation of zero. And if I push to infinity, I will get zero. Any questions on the zero part? All right, guys. I don't see enthusiasm, so I'm going to let you go. What I want to, what I advise you to come to the evening class if you have any problems with any of the material, and read the lecture on. We have to cover this and fundamental theorem of calculus, ideally before the exam, to have everything completed. Good? And with that, goodbye. I'm stopping the recording. If you want to stay for what, when, where, please do so. If not, I promise my German friend what, when, where. If she wants, I'll type to her.